When lava cools, as with pottery, magnetic regions form within it. Acting like microscopic compass needles, they record not only how strong the field is, but also in what direction it is pointing. Today, the Earth's magnetic field runs from south to north, which is why compass needles point toward the North Pole, and recent lava flows record a field pointing north. But 50 years ago, when scientists measured the magnetism trapped in older lava samples, they made a startling discovery. The microscopic magnets within the lava were all pointing south.
When we go back about 700,000 years, we find an incredible phenomenon. Suddenly, the rocks are magnetized backwards. Instead of them being magnetized to the north, like today's field, they're magnetized to the south.
It seemed that prior to 780,000 years ago, Hawaiian lava must have cooled within a global magnetic field that was running to the south and away from the north, exactly the reverse of today. The bizarre implication was that at some point, the entire global magnetic field had done a sudden 180-degree flip, completely reversing direction.
It was hard for people to accept. They did not like the idea that the field reversed. It took about 50 years to convince people of this. But eventually, that was established, and really by work on this island, because if you keep on going down, you would find that after about another couple of 100,000 years, then it changes again, and you see this sequence going on.
And as they examined samples from older and older lava, scientists found more and more reversals. On average, one every 200,000 years.
And so by the time people had done that, it was pretty obvious that the field did indeed reverse.
But if the field has reversed so often in the past, it must surely do so again in the future.
That the Earth's magnetic field reverses is an extraordinary phenomenon. But this reversal process is quite common. The last reversal was, 780,000 years ago. Before that, there was one about 200,000. Before that, again, actually less than 200. So in a sense, we are a bit overdue for a reversal.
So is this why the field is growing weaker today? Could it be getting ready to flip? Scientists needed to discover whether there was a link between changes in the strength of the magnetic field and changes in its direction.
It was a very intriguing problem, something that was screaming out for an answer, and computers were becoming powerful enough to actually solve a full set of equations that describe convection in the core of the Earth and how that motion generates a magnetic field.
In the 1990s, physicist Gary Glotzmeyer decided to embark on a very ambitious experiment. He put all the essential facts that scientists had learned about the Earth's molten core into a computer model, dozens of equations describing its dimensions, temperature, viscosity, and so forth. Then he let the model run to see how the magnetic field would evolve over hundreds of thousands of years of simulated time.
One case may take 6 months of running on the fastest computers in the world. I was using supercomputers from the Department of Energy, from NASA, and the National Science Foundation, and no matter where I was, the first thing I do is make sure the computers didn't crash. So it was something I did every day, 7 days a week for over 4 years. And I remember there was a period of time, I believe it was in the fall, and I was traveling to other universities and giving talks, and after a number of weeks I came back and decided, well, now I need to look at the details of the magnetic field, and realized that it was in the reverse polarity. It already had reversed. This is something I didn't expect. So then I looked at many snapshots during the time I was gone and realized that the field did indeed reverse spontaneously. This is the first time it happened We were very anxious to write about it. It was really exciting.
And as the experiment continued, so did the reversals, every 100,000 years or so of simulated time. And crucially, each time the field reversed, the process began the same way.
What's interesting is whenever it has reversed its polarity, its direction, that happened when the magnetic intensity was very weak. So it was decreasing, decreasing. Finally, when it was the dipole part of the field was very weak, then the field reversed.
Here was the evidence that what we are seeing today, a loss of field strength, is indeed linked to the onset of reversals. What's more, Gary could see why reversals are heralded by a weakening field.
Now this movie will show part of a simulation that spans magnetic field reversal. What you see here, blue represents inward directed magnetic field, the gold represents outward directed magnetic field.
In Gary's model, reversals seem to start with the appearance of islands of blue in the gold, and vice versa. These are magnetic anomalies, regions of the core where the field is already flowing the wrong way. As they grow, these patches where the field is reversed start to cancel out the main field, making it weaker and more liable to flip.
You see, as the time goes on, the field becomes more and more complicated, and then you get an anomaly growing in the northern hemisphere where magnetic field now is going out. There is a reversal. Now the magnetic field is outward in the northern hemisphere and inward in the southern hemisphere.
So now the burning question is what's happening in Gary's model reflected in the real Earth? Is the 300-year decline in our field, which the pottery reveals, the work of magnetic anomalies brewing deep in the core beneath our feet? If so, then a reversal really could be in the cards. And it's what this reveals about one region in particular that's significant.
We've seen very abrupt changes in the Earth's magnetic field beneath the South Atlantic Ocean.
Beneath the South Atlantic, Jeremy has found clear evidence for a region of magnetic anomalies, places where the field has already started to reverse. And these anomalies are growing.
As we get into the beginning of the 20th century, we see the emergence of a new patch of reverse flux, a region where the field lines, instead of coming out of the core, are looping back into the core. And that patch then drifts towards the west, hooking up with this other patch of reverse flux to create a large region, what we call the South Atlantic anomaly, where the field is about 30% weaker. And that patch has grown substantially during the last 100 years in particular. So one question we're all asking ourselves at the moment is the Earth's magnetic field about to flip?
In a region of the core 2,000 miles beneath the South Atlantic, the magnetic currents have reversed direction, canceling out the main field, causing its strength to decline. If things continue like this, then we could experience a magnetic phenomenon the Earth has not seen for 780,000 years. A complete flip of the entire global field.
There's really no question about whether the Earth's magnetic field will reverse again. The question is not if that's going to happen, it's when that's going to happen.
Scientists now know that the magnetic reversal that is inevitably coming will have serious consequences for our descendants.